Welcome back, everyone. I hope you've had a great lunch break. We are getting started with the second half of our day here at the CIREQ Interdisciplinary PhD Student Symposium on Climate Change. So welcome back, settle in, and it is my pleasure to reintroduce Geeti, who will tell us all about the presenters and the upcoming panel. Thank you.
Welcome back, everyone. So we are going to start our new session on climate resilience. We have our first...
Just hold on, Geeti. We're having troubles hearing you. Just one moment.
Okay, sure. I think, yeah, it's fixed. Welcome back, everyone. We are going to open new session on climate resilience. So our first presenter is online, Mohammad from Mecca University. Mohammad, you have 10 minutes. Please go ahead, and we will have a question and answer period after all presentations are done. Thank you so much.
Thank you very much, Kitty. Do you hear me?
Yes, we hear you.
Thank you very much. Hi, everyone. My name is Mohammad. I'm a PhD candidate at Maghreb University, and today I will talk about destructive thunderstorm winds and how we can improve the resilience of our communities to these events. So here we see a well-developed thunderstorm, and we know that it is capable of imposing significant damage to human-made structures. I guess we all remember the massive thunderstorm that hit Ontario and Quebec last summer. The wind gust of this event was around 30-40 meters per second, and it damaged a lot of households and trees in these two important provinces of Canada. In our recent research that was published in the Journal of Disaster Risk Reduction, we employed actual insurance wind damage data from the CIREQ database to investigate damage of synoptic and non-synoptic winds in Ontario and Quebec. We normalized data based on a reference year to consider wealth accumulation over time. And the wind catastrophes were categorized as convective storms, winter storms, tropical cyclone, and tornadoes. Our findings show that wind storms were responsible for more than $5.2 billion loss just in these two provinces and in the last decade. And this is a huge number. It comprises more than 60% of all types of disasters like flooding, wildfires, earthquakes, and so forth. Also, Ontario was damaged around 3 times more than Quebec, and this is mainly because of the eastward and northeastward storm trajectories. So storms were more powerful when impacting Ontario than when they reached to Quebec. Also, we know that there is a higher density of wealth and population in Ontario, including the GTA region. Our findings also demonstrated that nearly 70% of wind damage was caused by convective storms, which are mesoscale phenomena. Actually, these convective storms are governing the overall loss. However, the focus of current building codes and recommendation in Canada is on synoptic winds, like hurricane and tropical cyclones. So they need to be revised in this direction in order to achieve a higher level of urban resilience. Okay, after getting enough motivation from the first project, we started to look at the climatology of downbursts and environments supportive of these events across Canada. But what is a downburst? A downburst, as you can see in this video, a downburst is a volume of negatively buoyant air that is generated inside the cloud here, and it rushes toward the Earth's surface and spills out radially. For example, this real event happened in Nevada, and it caused a lot of damage. Again, for this part of the project, our findings was published in the Journal of Atmospheric Research. And for this part of the project, we obtained the downburst data from the Northern Tornadoes project hosted by Western University. They reported around 300 events for the past 4 years. And there's a high concentration in this part in southeastern Canada. And there are two reasons for this. First of all, it is because of a sampling bias, because this is a highly populated region. So there are more observers to see and report the event. And also the mentioned storm trajectories that I said in a couple of slides ago. And because of the time, I cannot explain everything about the methodology and results. We can talk after my presentation, or you can see my publication. Just as a highlight of our results, we propose a new index called Downburst Precursor Parameter, or DPP, by combining one dynamic and one thermodynamic index. And this DPP provided a better performance compared to other existing instability parameters for downburst diagnosis. After that, we use convective parameters to train several machine learning models to investigate downbursts in prone environments in Canada, and our results get published in the Journal of Applied Meteorology and Climatology. I don't want to go into details of this machine learning business and technicalities, but if some of you are doing research in this field, I highly suggest reading this paper. It really helped me to conduct this part of the project. We can, of course, talk after my presentation, or we can be touched in email. Again, just as an example, I can show you the performance diagram in this slide. The vertical axis is the probability of correct detection of a downburst or hit rate or true positive rate. And the x-axis, the horizontal axis, is success ratio, which is defined as 1 minus false alarm ratio. As you can see, the green one, the random forest model, is better approaching to the top right corner of the plot, that is characterized by a model that is capturing a lot of positive, a lot of downbursts without a lot of false alarm. So it shows a good model. Also, we use accumulated local effects technique to interpret how input features, how convective parameters are affecting the final prediction and outputs of the model. Accumulated local effect, or ALE, indicates the change in the probability of a downburst development. For example, if cold pool strength here, the x-axis, increases from 6 to 14 degrees Celsius, the accumulated local effect increases by 8%, which means that the chance of development of a downburst is increasing by 8%. We did this analysis for all the parameters, all the instability parameters, and we found a nice agreement with previous studies. So we can conclude that random forest has learned physical trends from the input convective parameters. And one take-home message from this study is that machine learning has the capability of being used as a part of the operational forecasting system to improve issuing severe thunderstorm and downbursts across Canada. Finally, to achieve a better understanding of thunderstorm winds in urban environments, I will numerically simulate these events using the impinging jet model. But what is the impinging jet model? In this model, we use a nozzle and put it at some altitude above the surface to produce an artificial impulse of momentum. So it can mimic the behavior of a downburst and thunderstorm outflow. And this model is widely recognized in the fields of wind and structural engineering because it can capture a lot of dynamical features of thunderstorms outflow. I will use CFD, computational fluid dynamics, to solve governing equations of the fluid flow. I mean Navier-Stokes and energy equation. And many of you know that when it comes to solving near building flow, we have to use very complex meshing and grid schemes like unstructured mesh. For the validation of the CFD, my CFD results will be validated against the wind tunnel measurements of Richer et al. This study. And we first obtained results for an empty chamber. So we have just ABL and jet flow. After that, we used and we added the Street Canyon model to see the interaction of a city, of an urban environment with the thunderstorm outflow. And after validation, we definitely can use the setup, the validated setup for other scenarios that were not applicable in the experimental study, like diverse event morphologies, different intensities for ABL and jet flow, and so forth. And just as an example of my preliminary results for this part, here you see the interaction of the ABL flow from left to right and the jet flow from up to down. And we see a very nice agreement from the CFD simulations and the conceptual model proposed by Romanich and Hangan based on the measurements. For example, the stagnation region behind the thunderstorms outflow or downburst is nicely simulated in the CFD simulations. At the end of the day, the numerically simulated and validated parameters like wind speed and wind direction, wind pressure on building surfaces will be used to hopefully contribute towards the potential future revisions of National Building Code of Canada and Quebec Construction Code to enhance the resilience of our communities to these events. Thank you very much. This was my research.
Thank you. Thank you, Mohammad, for your presentation.
Thank you.
Next, we have Robert from Western University, Ontario. He's going to share his insights on alternative analysis of winter road salts. You have 10 minutes, Robert. Please go ahead.
Can you hear me? Can everyone hear me?
Yes, we hear.
Okay. Thank you. My name is Robert Addai, a PhD candidate at Western University, Ontario. My research is about alternative analysis of winter road salt. We are talking about climate change and its effects. So why are we discussing winter road salt? So let's go through quickly because I have only 10 minutes. Yeah, snow and ice control is very important. And it is very important because I know some of you might have seen this before. When I came to Canada from Ghana, I nearly fell when I was walking throughout the snow. And maybe some of you too have experienced such thing before. So it is always important to control the ice, and it can also cause car accident because the snow or the ice reduces friction on the road. So it might also cause that. So it is important to control this for easy passable of pedestrians and also increase friction for the passage of cars and other vehicles. So the most common way of controlling is by the use of salt. What does the salt do? The salt also helps to melt the ice faster and also increase friction for easy passable, like I've already said. And the most common salt that is commonly used in Canada here is sodium chloride. So the effect of the salt is my interest because, as Newton said, to every action there is equal and opposite reaction. So we are looking at the reaction of the salt to the environment. So some of the reactions or the effect of the de-icers are, those of you using cars, maybe you might have seen this corrosion on the part of your car. And also bridges are being corroded, infrastructures are being affected, and it is affecting the environment as well. And also grasses are being dying up because of the high amount of chloride being released into the environment. Trees are dying, and we also know that when the last tree die, the last man will also die. So it is important to look for alternative salts that will be environmentally friendly. Quite apart from that, we have freshwater salination, where freshwater being the salt during the winter month, the salt melts into the fresh water. So the amount of chloride released into the fresh waters are increasing. Therefore, some organisms in the fresh waters are also being dying up. So it is important for us to look for salt that are environmental friendly. So the aim of our research is that we have seen a lot of research on this topic, but most of the research end up in the laboratory. But for us, we are looking at analyzing different road salts and optimize their benefit in terms of their corrosivity. We are looking at environmental impact and also ice melting performance. And the lastly, cost. The cost here might be you may buy a salt which is cheap today, but we are looking at its cost in the future. So if you have a salt which is expensive today, but it is good for future. We can quantify that one to ensure much more benefit to Canadian municipalities using those sources. So these are the material that we are using for metals. We are assessing this, that is the corrosion aspect, mild steel, high strength steel, galvanized steel, stainless steel, and aluminum alloy, and also concrete sample. And the salt that we are using, of course, sodium chloride is the most used. So we are analyzing the other one, potassium chloride. So here we have to categorize them. We have the chloride-based salt. We call it inorganic salt. And we have the 7 and 8 are chloride, the organic-based salt. The 8 is a chloride-free blend, that is CFB flake. It is produced by Taifa Environmental, which is situated in Winnipeg. And also, we have a mixture of them, that is calcium, magnesium acetate, and sodium salt used by Western University facility. It is sodium chloride plus some traces like organic salt, sand, and other stuff. So we are testing all these salt. So for our experiment, we are looking at laboratory and also the field. So for the laboratory, we have ice melting performance, we have corrosion, we have environmental impact, and also the field, the same thing. We are also checking the environmental impact, we are checking of corrosion and ice melting performance. For the purpose of this, because of time, I will just brush through only the corrosion aspect. So this is the side view of what we did last winter for the ice melting performance. And this is the corrosion aspect, what we did for the corrosion also. So these are some of the visible changes that we saw on metals. We saw that after week 1, so before exposure, the metals were polished, we didn't see any corrosion. But after week 1, we saw that the salt were corroding the metals. Week 5, it was worse. And week 10, it was getting worse. So we analyzed this using 10 weeks and it was getting worse. But we could see that among all the salt, these ones are not corroding. The sodium acetate and CFB, which are organic salt, they are not corroding the metals. So we can make case for this one. So we use so this is ice melting performance. I will not dwell into this one. We use scanning electron microscopy to check how far or how the salt have damaged all the metals. And we saw that, yes, all the metals were damaged. If you look at aluminum alloy here, our body parts are made of aluminum alloy. We could see pitting corrosion. If you look at mild steel and high strength steel, mild steel is a steel that is used in concrete and they are all damaged. So it is a problem. But the good thing is that the organic salt, sodium acetate, and CFB flake, they are fine. They are not corroding the metals as we want. But here, chlorides and mixtures are damaging the salt, are damaging the metals. Quartz, zinc was sacrificed. So the galvanized steel, we saw that all the zinc was sacrificed. And here we cumulated the mass loss. This is what we did. Before exposure, we weighed the metal with balance. And after exposure, we weighed the metal again. So the difference of this mass were cumulated here. So which one corroded much? And we could see from here is that from 1 to 4 are the chloride-based salt, that is the inorganic salt, and the 7 and 8 are the inorganic salt. So we could see that the organic salt are not corroding much. So they are better in terms of corrosion, whilst 1 to 4, that is the chloride-based salt, are also corroding the metals. In between 5 and 6, they are also corroding. So if you want to make case for which salt to be used in Canada in terms of corrosion of metals and infrastructure, then we can go for the organic salt. But can we make case totally for the organic salt? We further look at concrete fiber. So we sprayed the salt on concrete and we saw it. So these are the metal in the concrete and it was analyzed by micro-CT. So all these are the metals. So it is interesting to know that the inorganic salt, the chloride-based salt that are corroding the car body part, the infrastructure, they are also not corroding the concrete. But the organic salt that are not corroding metals outside, they are rather corroding the concrete. And the mixtures are worse. So if you are a city engineer, if you are a policymaker, and we presented this results to you, which one will you choose? Will you choose a salt that will corrode metals but will not corrode concrete? Or will you choose a salt that is not corroding metals but will rather corrode concrete? Which one will you like? Maybe we lead that one to corrosion. So our conclusion is that inorganic salt corrode infrastructure and metals more than organic salt. And organic salt corrode concrete rebars more than the inorganic salt, but a mixture of them is worse. Thank you. If any question, you can ask.
Thank you, Robert. Next, we have Marie Launay from Department of Natural Resources from McGill University.
Okay, so hello everyone, my name is Marie and I'm a PhD candidate at McGill University, and today I would like to present you the first chapter of my PhD, which focuses on assessing the link between the ontogenetic shift in GWK density and the diet composition of the Arctic cod. So first of all, let me introduce you to the main character of my study, which is this tiny silverfish, Berrada, commonly named the Arctic cod. And if I decided to focus on that fish, it's because he's very important for the Arctic ecosystems, and I will show you why. So he consumes zooplankton that rely themselves on ice algae, and then is himself consumed by larger predators such as marine mammals, piscivorous fish, and also marine seabirds. So you can see that he transfers energy from the lower trophic level to the upper trophic level, meaning that he has like a very central role in the Arctic ecosystems, and so he's like very important. Another characteristic is that he is the most widespread and abundant species across the entire Arctic Ocean, as you can see on the map. And he also occupies like a wide range of habitat and depths, as is present through the entire water column. But the main characteristic of the species is very important today because of the actual climate change, because these species live in close relation with Arctic sea ice. In fact, it spawned right beneath the ice, and the younger and small fish try to stay here for as long as possible, where they fed on copepod nuclei and eggs, before shifting to deeper water when they get older and bigger. And here, they broaden their diet to include large copepods and amphipods. But the mechanism behind that shift is still unclear to the scientific community, and I was trying to figure it out. So last year, with my previous undergraduate students, we've done two types of morphometric analysis. The first one was on the external shape of the fish, and the second one focused mainly on the internal morphology, so the GWKs that are on the side of the fish and that are linked to feeding morphology, and it's just like filtering stuff where they can like sieve out prey. And so for the first one, we didn't find any habitat-specific morph, at least in the Beauforty, so we conclude that there is no shape. But for the GWK density, we have found like an interesting patterns, and so here are the results. So in the Beauforty, you can see that there is a significant decrease like into the GWK density after age 1. So that means that the younger fish do have like a higher density of their GWKs compared to the older one. And we've run the same analysis on some Norwegian fish that have been sent from some collaborators, and you can see again that there is that decrease into like the GWK density. So from that observation, we decided that maybe there is a link, and maybe this is because of the decrease of the GWK density that they shift their habitat to deeper water. So maybe as the GWKs are too sparse, they cannot sieve out and retain like the small prey such as copepods and nuclei, and so they have to go deeper to find like larger prey that are more adapted to their sparser GWKs, and so that's maybe why they are moving deeper. And so that's what I've been doing for my first chapter. So to do that, I had 100 samples from 10 sampling sites across the Beauforty. I will pass on this one for today, I think, because I won't have time. But the first analysis that I ran was the same as previous year. So I redo like the GWK density. So the idea was just to take off the GWKs of my fish, to count the GWKs and measure like the gill arch. And from that, I calculated the density of the GWK. Then I've been doing some gut content analysis. So here again, I just dissect the fish, take out the gut contents, and I've done two analyses. So the first one was to identify the diet item at the lowest level possible, and it was long to do. And then I measure each of the diet item size to have an idea of the size of them. And then I've run some stable isotope because like for the gut content, it's good, but it's only give us insight on the recent consumption of the fish, and we wanted information over a longer time frame. And so we take into consideration 3 isotopes. So the first one was the nitrogen that give us a trophic level signal. The second one was the carbon that give us insight into the organism habitat. And the last one was the sulfur that provide information about proximity to fresh water. And we were having very high hope with this last one because, as I told you, like the young live near the ice, so like fresher water compared to the old one that live like into like the deep marine salty water. So we were hoping to see a very cool pattern here. So for the CIREQ density, without any big surprise, we see like the exact same pattern. So you can see that there is a decrease in the CIREQ density, so that just straighten even more our initial hypothesis. And moving to the diet item. So for the identification, it was very hard to do because like the main bias of the gut content is that majority of the gut content is too digested to be identified, so it was sometimes hard to do. And you can see that our results are not as good as we were hoping because like there is a lot of category other that were like the items that were too digested to be identified. But the cool thing that we can see here is that the nuclei in the bluish color here are mainly found in age 1 fish. So that means that there is a correlation between like the higher density of CIREQs and the small item that you can find. And we confirm that trend with the measurement of the diet item. And you can see here that it's very clear. Age 1 fish do feed on smaller item than age 2, 3, and 4. And so that means that there is a link between the ontogenetical shift in CIREQ density and the diet composition of the fish. And so moving to my last result, the stable isotopes. So here we've run a pairwise comparison. And so the first one was between nitrogen and carbon. And here you can see that, again, there is a clear pattern, and the difference between age 1 fish in orange and the other category of age is mainly explained by the y-axis, which is the nitrogen. So that means that age 1 fish do have a lower trophic signatures than the older fish. When we compare with the sulfur, we see the exact same patterns, like the difference is explained by the y-axis, meaning that age 1 fish do feed at a lower trophic level than the older one. But when we take a look at the sulfur and carbon, we were a bit disappointed because we didn't see any difference. And as I was explaining to you, like because of the sea ice, I was hoping to see something cool. But I think that it's mainly because like all of my fish are, after all, marine fish. So like the difference between the icy water and the deeper marine water is too subtle to be seen with the sulfur. So yeah, that's why we didn't see anything, but that's fine. So yeah, in conclusion, you can see that there is a significant correlation that was observed between the CIREQ density and the dietary preference of the Arctic cod based on age. And so I think that the decrease in CIREQ density prompts the Arctic cod to shift their dietary preference and move to deeper water to consume larger prey. So as I was explaining at the beginning, I think that because the CIREQs become too sparse to retain like the eggs and the nuclei, they have to find something that is more adapted to their sparser CIREQs, and so they have to shift their diets and their habitats so they can just feed properly. And so now I'm still working on the same species, the Arctic cod, but I'm doing some genomic study. And the plan is to do a whole genome resequencing to assess the population structure of the fish, do some genome-wide association study to link that with the environment, and also do a transcriptomic to see the genetic basis behind the ontogenetic morphological shift of the CIREQs. And so maybe for the one of you that are not familiar with the ecological field, I will just take like a little step forward and just tell you why is it important to do such type of study, because maybe some of you like are not very understanding. I think that nowadays, because of the global change, like all of the ecosystems and species will be impacted in a way or another because of everything that is going on. And so it's important for us, the ecological community, to give information to the government and the industry so they can take informed decision on, I don't know, maybe the implementation of MP or some new fishery developments. And so that kind of information are very important for them so they can do stuff that won't harm even more some species. So that's it for me. And yeah, I just wanted to thank the McGill and everything for financing this project, the DFO for the sample, and all of my lab for their help. That's it.
Thank you, Marie. Our last but not least presenter is Pita from School of Environment, Resources and Sustainability, University of Waterloo.
Hello, everyone. Oh, I'll just wait for the slides to show up. Perfect, thank you. So hi, everyone. My name is Katie. I'm a third-year PhD candidate at the University of Waterloo. Thank you so much for the introduction. I study with Dr. Andrew Trant, and I primarily study forest ecology through a historical perspective. My research is primarily based in the south of England, and I just spent May 2023 there, as well as May of 2024, so I've just come back to share with you some of my work. So today I'll be talking about how these old historical and traditional woodland management regimes offer us one way to mitigate some of the impacts of climate change. So let's get into it. Oh, right, I hit the slides. That's funny. This is just a quick agenda of all the things I'll be talking about today. And so let's get into the research context. So forests, broadly as we know, are threatened by climate change, but they can also represent a nature-based solution to it. Because trees can both help take in carbon from the atmosphere, and they can also help with the regulation of surface air temperature. So therefore, ensuring that woodlands are resilient to climate change is very important. And one way that we can do this is through the use of these traditional and long-standing management regimes that have been around for thousands of years. And because they've been around for thousands of years, this means that they must have been successful under previous periods of extreme climate disturbance. And furthermore, these regimes typically emphasize something called spatial heterogeneity. And spatial heterogeneity occurs when landscape structures and features are variable across an ecosystem. And so this, again, increases that ecosystem's chance of resilience under disturbance. So the traditional woodland management strategy that I am researching is called coppicing. And so coppicing resembles typical tree harvesting methods that we have here in North America, except with one major difference. So tree stumps in coppicing are left behind after harvest. And in the literature, these stumps are referred to as stools, coppice stools. And so after harvest, the stools are left to regenerate new stems. And over time, all of these stems grow and they're not pruned, so they're all growing at the same time. There are a few benefits to this type of harvesting, including the fact that all of the stems that have grown throughout time are genetically identical to one another. So that means that the older the tree stump is or stool is, the longer its genes have stood the test of time. And this harkens back to that idea of long-term resilience. Next, because they grow quickly, they can also be harvested very quickly too. So for some species, a full harvest cycle can be as short as 5 years. And that means that those trees can actually sequester more carbon more quickly as well. And last, because the roots are never disturbed in the soil structure is maintained over the long term. So as I just described, coppicing specifically offers us lots of benefits or ecosystem services that are helpful to people, as well as offering more general ecosystem services that all forests contribute. And so in my research, I am particularly interested in how coppicing provides biodiversity of plants, as well as carbon storage. And so particularly, I'm interested in the cyclical nature of these two ecosystem services. So when are they highest throughout the coppicing cycle? Does biodiversity peak at the same time as carbon intake peaks? Or do these two things happen at different times? And if they do happen at different times, what does this mean in terms of trade-offs between the two? So how should people manage values for one service over another? And so this brings me to my research questions. The first being, how does understory plant biodiversity change throughout the coppicing cycle? Second, how much carbon do coppice trees store throughout their cycle? And third, do these two ecosystem services peak at the same time or at different times? So to answer these questions, we traveled to a place called Bader College, which is located in Sussex, England, where coppicing of sweet chestnut trees has taken place both historically and is still active today on approximately 20-year cycles. So this is an aerial overview of our study site. On the left here, we have the harvest dates, the most recent harvest dates of each coppice stand. And we can see that some stands are listed as unharvested or unknown. And so these stands were categorized as abandoned stands, meaning that they've likely gone more than 30 years without being harvested. So, because coppicing takes place on this rotational basis, similar to any other tree harvesting system, we used a chronosequence approach, or space for time substitution, to represent the different years of growth of coppice trees and woodlands. So in these 17 stands, which again were a variety of ages, we measured understory plant biodiversity and another variable called above ground biomass of the sweet chestnut trees. And above ground biomass is basically just an indicator of how much a tree weighs and therefore how much carbon it stores. So a heavier a tree is, the more carbon it stores. And lastly, we also did some photography of the tree canopy to evaluate how open or closed it was throughout the cycle. So in our study design for biodiversity, we established one 400 square meter plot in the center of each coppice stand. And in that plot, we identified every plant species that was growing under 2 meters in height. And we used a software called iNaturalist to do that. And this took place in May of 2023 and May 2024. In terms of the biomass study design, this was a little bit different. We measured a few variables in the field. We first selected 10 random trees in each coppice stand, and we measured of those trees all of their stems diameter, as well as the overall tree height. And then the second thing we did was use a novel remote sensing technique through an iPad app called Pix4D Catch. And so the app makes use of LiDAR technology to generate a 3D model of the tree in real time. And the purpose of this is to see if the same variables that we measured directly on the trees could be gathered remotely. So to jump right into some very simple and early results just from 2023, these box plots show the average number of unique plant species growing at actively managed coppice stands versus those that have been abandoned. So we can see that the actively managed stands have a higher variability of the number of unique species. And when we look into that actively managed stand category in a little bit more detail, we can start to parse out how biodiversity changes through time. So the reason for this higher variability is because these younger stands are contained in the actively managed category and represent those stands with higher species richness. So in this graph here, we can see that biodiversity is highest within the range of 2 to 6 years approximately, and then drops off after, and it never really fully rebounds. So the question is, why are we seeing this trend? Well, we think primarily because of the closing of the tree canopy over time. So this is illustrated by these photos I took. As light conditions in the stand become more homogeneously shady, only the shade-loving plant species will be able to continue to thrive, while the more shade-intolerant or sun-loving species are less able to survive and proliferate. In terms of biomass results, we're seeing something a little bit different. So at this time, I actually don't have too much to say about the 3D models of the trees because that analysis is pretty involved. But I did think it would be nice to include a visual of how we can use these 3D models to represent real structural changes in tree growth over a coppice cycle. I do, however, want to talk about those two variables that we measured directly, which are stem diameter and tree height, which we're using to indicate sweet chestnut biomass and therefore carbon storage. So we can see here that both diameter, or DBH, and height are increasing pretty steadily throughout the coppice cycle all the way up to 21 years. And these graphs look very different from the graphs that we just saw on biodiversity, which peak 2 to 6 years after harvest. So what does this mean then for management? Well, I think it means a few things. So capturing these real-time trends in ecosystem services means that managers can potentially optimize their regimes better in order to maximize those services. So when we're thinking about carbon sequestration in particular, this is a really important climate change mitigation strategy that is valuable to many people, and understandably so. However, we also need to recognize that by maximizing one service, we may not be able to gain all of the same benefits from another important ecosystem service, which in this case is biodiversity, which peaks much earlier than did carbon storage. And lastly, by generating data-dense 3D models of these trees, we can begin to build large libraries of data that will persist long-term. And so these can help us explore the answers to my questions and potentially understand other types of ecosystem services as well, helping us to unravel the complexities of managing for climate change. Thank you.
Thank you, Katie, and thank you all our presenters. Now it's time for Q&A. If you have any question, you can raise your hand, and our Zoom attendees, they can put their question on the chat box.
Hello. Okay. My question is for Robert. Are you still there?
I'm here.
Okay. I was wondering because I've seen recently that, or at least in Montreal, we use sand and rocks a lot to prevent ice slipping. And the reasoning I think behind it is that we can reuse the rocks for later years. And I was wondering if you had any inputs on the usage across Canada and whether it affects the environment in a different way. Thank you.
Okay. If you come to Canada, different provinces have different sort or different way of controlling their ice. Especially if you go to Montreal, somewhere like Saskatoon, the amount of snow there is different from Ontario, because Ontario, even this winter, we were expecting a certain amount of snow, but we didn't get. So if you go to Saskatoon, for instance, they cannot use the sodium chloride that we are using here. So mostly they use calcium chloride, because calcium chloride has high melting point than even high melting performance than the sodium chloride that we use here. So maybe, probably, I may not get the exact reason why they use the rock and sand. Maybe it is because of that. Maybe the amount of snow that they get there is higher than the other areas. And we know that gravels increase the friction of the road. And if you go to Europe now, some countries are banning the use of salt because of the effect of the salt. Even in Canada here, we have beach, we have different ways of controlling the ice without using salt. Some people are trying different ways. So maybe they have also seen the effect of the salt. That is why they are using other one. But one thing I can say generally is that as I'm speaking with you, I'm in Winnipeg. We have seen that they are also trying to use different form, like the rock and other stuff. But the amount of sand and the amount of dust that also living after the winter month is also another issue that we are discussing here. So that is what I can also tell you now. So I don't know if your question is answered.
Yes, he's giving you the thumbs up. I don't know if you can see. Thank you. Our next question here.
Thank you. Question for Marie, just asking a clarification and a question for Katie. So Marie, I just not quite sure I understand the role of the carbon isotope. I think I get what you're tracking with the nitrogen isotope and with the sulfur isotope, but I wasn't quite clear what the distinction is of the carbon isotope. And then let me just ask Katie's question, and then I'll come back to you. So Katie, I'm just wondering about the species, the sweet chestnut, and in terms of a management strategy, how many tree species are suitable for coppicing, assuming that there are only certain kind of environments that are really best suited for sweet chestnut. So Marie, if I could sort of go back to you with your carbon.
Yeah. So for the carbon, it was like mainly the localization of the fish. So in the result that I show you, like all of the fish came from like the Beauforty, but like from multiple sampling sites. So maybe we can see like difference, but in that case, like we didn't see anything.
So the geographic placement in terms of, okay, got it.
Because we do the same analysis like with sampling that came from Baffin Bay, and here we do see like a difference between like the carbon signatures of different locations. So
Thank
that
you.
was that.
Thank you.
Yeah, so, is this, okay, there we go. So yeah, sweet chestnut is just one species that can be coppiced. Essentially, you could probably coppice almost any deciduous species. You can't do it with coniferous trees, they just won't regenerate. But basically any tree that has leaves, you could probably coppice it. Really the reason why we don't do it here in Canada, North America broadly, is just because of like historical differences. Large scale modern day forestry is trying to produce like very large quantities of wood, and wood for specific purposes where the tree stems have to be of a certain diameter in order for that wood to be useful for that purpose. So like buildings and construction and things like this. Coppice wood, because the cycles are shorter, typically the stems that the trees are harvested with are not as big. So it's mostly used for stuff, historically it was used for fencing and for something called wattling. Yeah, so not really, those stems don't necessarily get as big as we would picture, like a stem that would be used for like a ship mast, for example. But yes, there certainly are lots of other species that do get harvested. Sycamore is another common one. And chestnut specifically wasn't actually, so the site that I'm studying at is in England, where sweet chestnut is not actually technically native to England. It came over during Roman times with the Romans and has been naturalized there ever since. But that doesn't mean that you can't harvest it for wood. So yeah, I don't know if that answers your question. Great.
Hi, everybody. I just want to say I enjoyed everybody's presentations. They were all really insightful. But my question goes to Marie, specifically about the locations that you decided to choose in the Beaufort Sea. I believe that location, it was just south of Banks Island and in between Banks Island and mainland Canada. And typically that area, as of right now, is not seeing as much multi-year sea ice other than other regions in the Arctic. And obviously, like you were saying, younger fish do kind of go underneath the ice. Have you considered potentially changing or doing a comparison between locations where there might be full year sea ice presence, just to see if there's maybe between the carbon variables, the sulfur variables, and I think it was phosphorus variables that you were mentioning, maybe there would be significant differences in those geolocations while still staying in the Beaufort Sea?
Yeah, that would be good. But like, as you probably know, like it's difficult to get sample from the Arctic, like it's costly and it's sometimes difficult to send ship over there. So like I'm taking what the DFO give me, and like for now we don't have that kind of sample, but that would be nice to have that kind of information for sure.
Just a question about the coppicing, because you found that there's a decrease in species, so understory species of plants. But if I'm seeing a lower, more canopy, then there's more humidity, more humus, more carbon in the soil, which then makes me think that there's probably like higher diversity actually in the soil of insects or like invertebrates in general. Have you is someone doing that part of the study?
Yeah, that's a great question. So there are definitely studies that look at other aspects of biodiversity of coppicing ecosystems besides just like understory plant species. There's one in particular that looks at butterfly biodiversity under coppicing, and they also found that under coppicing as compared to other forest management regimes does have a host a higher biodiversity of butterflies. I don't know about other insects or invertebrates, but I would imagine probably something similar, especially because because coppicing harvesting is happening really frequently, you're getting fresh inputs of dead wood into the soil more frequently as well. And so dead wood is a common habitat for lots of invertebrates, and so would probably host more of those as well, would be my assumption.
Any other questions? Yes, I see one back here.
Thanks. My question is for Robert. So you mentioned that one of the considerations in your research is how the salts are affecting the environment. And so I saw a picture, maybe you're looking at soil and perhaps some plant growth with those salts. And so I'm wondering if you could just tell us a little bit more about what you're doing for that, and specifically if you are growing plants in some of the saline soils, or what plants you've chosen to look at.
Okay, thank you for your question. What we are doing is we are looking at the amount of chloride in the soil, because you know that chloride can affect the plant growth, the soil, the amount, the animals in the soil, because for plant or grass to grow, we normally need some living organisms in the soil. And this chloride also affects this earthworm and other organisms in the soil. So what we are doing is we take soil sample from where closer to the root side. Then we analyze. Then we take another soil sample from where we think is not closer to the root side, where the salt might not be affected. So we bring it to the lab. We use some techniques like ICP-MS. We digest the soil sample with nitric acid, and also use ICP-MS to analyze the amount of metals found in the soil. So normally, if you see more of maybe sodium, it tells us that maybe we may have more of sodium chloride in that soil sample. So at the end of the day, we are going to compute all of them and see closer to the root where we spray the salt, and far from the root where we do not spray the salt, how much soil or how deep does the chloride penetrate into the soil. So we are looking at the penetrating level, how much chloride we have in the soil, so that we can, at the end of the day, tell our results. But we are still on that one because we just started the last winter. So we have now taken some soil samples in the lab that we are working on.
Thank you.
But the most important thing is how deep that the chloride gets into the soil. Because when the chloride gets more into the soil, living organisms that help plant growth and development may die, and it may also affect the nutrient of the soil.
Thank you.
I have a question for Mohammad, if he's still on the line. Mohammad? If he still is on the line, my question relates to risk. Whenever somebody uses the term risk, I think of insurance companies. And I'm just wondering, Mohammad, who is the main audience for your research, or the parameters and the design of your experiments? How much are they tailored to different potential users or end audiences?
Thank you for your question. Actually, the main audience for my research is the decision makers in the field of building codes and wind recommendations for building construction. Because the current building codes are based on synoptic winds, so our research showed that the main damage is caused by synoptic, not caused by synoptic scale winds. So I want to revise and improve the building codes in this direction.
So political and regulatory then, mainly?
Yes.
Thank you.
Okay.
Do we have any other questions? Oh, yeah.
Just as a follow-up, just kind of stemming off of your question, and it's going to be posed to Mohammad as well. Have you ever considered looking at potentially engaging with development firms and urban planners to further implement and try to gain traction regarding those theories? Because then those are typically the, if not people in regulatory positions that are able to make the policies, having other people on the other end of the spectrum that are implementing them possibly advocate as well. So you're getting at both forefronts.
Mohammad, are you still there?
Do you hear me?
Yes, we do hear you.
Actually, I recently was in a conference for insurance industry. Many of them are aware about these potential deficiencies in the wind loading recommendations and building codes. But the problem is how to implement research and connect them to the industry. There is a large gap between industry and research in this field. So my main problem is just maybe to take one small step in this direction. Maybe we need a decade of research to do a small change and revision in building codes.
He's giving you a thumbs up, so thank you for that, Mohammad. Do we have any other questions? Oh, yes.
Thank you. I was curious for the research on the Arctic code. So do you have a sense of what are the implications of this differences in morphology between the younger fish and the older fish in terms of seeing ice melting faster? Will this make smaller fish more vulnerable, or will they thrive? Like, what can be the implications for the survival of these fish? Just out of curiosity.
I don't have like a very precise answer to this question, but I think yeah, it's like alarming to see that these fish depend on the ice algae, and like they depend on zooplankton that relies on ice algae, and they spawn right beneath the ice. So if the ice tends to disappear completely, I think it will be like difficult for them, and they will have to find a way to adapt. And yeah, for the next chapter, I will try to study like the resilience of that fish and how it can adapt to its new environment. But I think that the trend is not very good for the species.
Oh, okay. A follow-up from what Regis said, and sorry, I forgot your name. Yes, but the region where you looked at, apparently there's less ice than before, and but have you seen a composition change from that region? So nowadays the ice won't be there year round. So have you seen already a composition change in the young cod?
I don't know, because like I know that my sample came from 2018 and 2019, but like they can go like here every year and stuff. So no, I don't have like a huge time-lapse data, so I don't see any change yet, but yeah.
Okay, thank you.
And kind of following up here, sorry that we're all just kind of asking active questions about Arctic cod, but one question, if it's not a change of location, is it change of potential breeding patterns or seasonality amongst when the Arctic cod are kind of getting bigger? Because I know that with the data collection, I think you could see in some of the graphs, it looked like they're all close to like the 1 year mark exactly. I don't know if that was just based off of showing the data in one way, or if it was potentially like the data points were collected throughout the year, if that makes sense.
I know that the DFO is going like the CBS MIA project, like it's every year, like in August, if I'm saying well. So I think yeah, it's in August, like every year, like they go there. So yeah, I don't know if it will change like the patterns of their reproduction, but I know that there is like a huge shifting like in their habitat, like they are going way up like in the north, and so like yeah, that's a big change that we can already see.
Perfect, thanks.
Marie, another question for you. A Norwegian biologist once told me that the distinctive thing about fish is that they have incredible genetic plasticity. I've not followed this up, I've only heard this one comment, but I'm just wondering in your future research on genomic analysis, whether that genetic plasticity is going to be a factor in adaptation. Like, is the genomics a baseline that you're going to be looking at, or are you going to be considering potential temporal changes in the genome of the fish?
Like with the whole genome, like I won't be able to see like temporal change, but yeah, I will take a look at the baseline. Like I will have like circumpolar specimens, so I have from Norway, from Greenland, from Russia, and from Canada. And the idea is to see like how similar they are genetically speaking, or if there is like different population. And yeah, that will be helpful to implement like real management plans and to see like if we can do like a one big conservation plans across the entire Arctic, or if there is like some specificity that we have to take into consideration for each population.
Thank you so much. That's all the time we have for questions, but we encourage this conversation to continue throughout the day.
Thank you so much, Al. It's time to wrap up the session, so you can continue your discussion with our presenter during the break. We have 20-minute break, and then we will have our last session at 2:40. Thank you. Enjoy your break.
Welcome back, everyone. Thank you. We are ready to move on to our next panel. And here to introduce is one of the co-organizers of today's events, Alexandre. Take it away.
Welcome back, everyone. So for our last panel today, we will talk about sustainable transition in industry and finance. So for our first panelist, I introduce you Abdoul Aziz Berrada from HEC Montréal, who will tell you about volatility between green stocks and brown stocks. You have the floor.
Good morning, everyone. For this presentation, we'll talk about the impact of climate change concern on the volatility of green and brown stocks. So this is a work in progress with David Ergia and Kevin Bluto and Pierre-Olivier Pinot. Thanks. Oh, sorry. So the goal of this study is to shed light on how major coverage of climate change concerns will impact the volatility of stocks. So we will divide the stocks as green or brown based on their environmental impact. So we want to do two things: to quantify the relationship between these concerns and the volatility of the stocks, and also to differentiate the impact between green and brown stocks, to see if we can have, on average, a significant impact between green and brown stocks, impact by, let's say, an increase of climate change concerns. So to do that, we need a measure of volatility. And to measure volatility, we will use the, let's say, a theorem from stochastic volatility models. So we want to approximate the integrated variance when we don't have jumps in markets by the quadratic variation. And if we want to do that, we will estimate it by using the realized variance. So we will choose a measure of a monthly realized variance that we will calculate by summing the square of returns. So to have a monthly measure of the realized variance, we will sum all the daily returns. So a return is, let's say, a log return. It's the percentage of increase or decrease of the price. We also need a measure of climate change concerns. So this is an index that we constructed. So it's an index that will capture monthly variations of climate change concerns covered into many media, let's say, newspaper and newswires. I will come back to this. And since we want to discretize and divide stocks between green and brown, we also need their environmental dimension ratings. So we will use in the ESG ratings, the E rating. We have also many specific variables as controls, like the bid, ask, and the market value. And we will use a data range of, let's say, from 2013 to 2022. So, like I said before, we classified all the stocks between green or brown, and to do so, we did it in two steps. So first, for each month, we not normalize, but we adjust the environmental rating of each of the stocks by the mean of all the stocks. So let's say in December, for the stock April, we took the rating of April and we subtract the mean of all the ratings for that month. So the mean of the rating of Tesla, Microsoft, and all the stocks. And if that difference is positive, we will see that, hey, this stock is green. And if that difference is negative, the stock is brown. And you can see in this plot, in blue, you have the green stocks, and in brown, you have the brown stocks. And we can see that the green stocks are increasing. The number of green stocks in our sample is increasing. I think this is a sign of, let's say, a sustainable practices. The companies are more interested into green practices. So the ESG rating is increasing. That means they are more and more into sustainable development and sustainable investments. So this is our index of climate change concerns. This is a time series index that we construct using two lexicons, a risk lexicon and a sentiment lexicon. What we did is to go and download many articles from Washington Post, from Wall Street Journal, and in each of these articles, we use lexicons to say, can we find some risk words or some sentimental words, some sentiment words? And from that, we can compute for each article a sentiment index. And for all the articles of each day, we can have a measure of the sentiment. And you can see from the 30-day moving average that we can capture by the spikes many events, many climate events. You can see in 2010, we have the Copenhagen UN climate change concern. You can see also in 2012, you have the Doha conference. So you can see that we can capture all the main conferences. Okay, so we have our measure of volatility, we have our measure of climate change concern. So how do we model that? We will do it by using a dynamic panel data model. So it's dynamic because we have in the right-hand side a lag of our dependent variables. But we are interested in the intersection, so the green part of the equations. This is the more interesting because we want to know the impact of the volatility of the major climate change concerns on green and brown stocks. So if that variable, let's say that estimated parameter is negative, that's good for us because we think that an increase of climate change concerns will decrease the volatility of green stocks because they are less risky. And why do we think that? Because of two main reasons. First, we have investor preferences. Investor will invest in companies that are more aware about climate change. So investing more and more will make those companies less risky. We think also that green companies are in the long term more financially stable because they are in alignment with trends in energy transition and sustainability. So this is the estimation part. How do you estimate that? I'm not going into all the details, but we have a big problem in econometry and in finance, which is endogeneity. And to solve this problem, we will use this estimator, which is the system estimator. So what we do here is to have different, I'm going to come back here to show you. Here we have fixed effect, the CI, the individual fixed effect, and the time fixed effect. So if we have a dynamic panel model, if we want to estimate it, we should get rid of the individual fixed effect, because if we don't get rid of this CI, there is endogeneity. And if you have endogeneity, our estimation is biased. So the OLS estimation and the fixed effect estimation will be biased. So we do it, we estimate it using what we call system GMM estimator. System GMM, not Gaussian mixed models, but the general method of moments. And let's go through the results. We have this table. What is good is, if we look at the first line, we can see that, let's look at the column number 6. The estimated parameter is 0.354, which is between the coefficient estimated for the column 1 and column 2 that are biased. So our estimator is bounded between these two bonds. So this is good for us. And our parameter that we are interested in is the parameter estimated in the last row. So let's look last row and column number 6, which is minus 2.083. So the sign is good, and what we can see from this estimation is, if we have an increase of the climate change concern by 1%, on average, we'll have a decrease of the volatility of green stocks by 2% compared to brown stocks. And that's the end.
Thank you for your presentation. Next up, we have Kirthana Singh Kurana from University of British Columbia, who will tell us about natural law perspective on ESG compliance. You have 10 minutes. Go ahead.
Good afternoon, everyone. Today, I will be delving into the ethical backbone of environmental, social, and governance standards through the lens of natural law. Now, I do understand that not everyone here is a lawyer, and you must be wondering what natural law stands for. Natural law is basically one of the legal theories that we study under the subject of jurisprudence. And it sort of presents law as a system of rights or justice held to be common to all humans, and it is derived from nature. It is based on close observation of natural order and human nature. Now, why natural law? Because it challenges us to ponder not just the legality but the morality of our actions. Are we merely following rules, or are we guiding our corporations toward a greater good that benefits all? Now, as we embark into this exploration of ethics in action, I invite you to reconsider the fundamental notions of right, duty, and justice in the corporate world. Let's unravel how ancient wisdom can illuminate modern challenges, ensuring that our businesses do not just operate, but thrive responsibly and justly in our shared global society. Now, the ESG movement principally refers to the growing focus on sustainability and social responsibility in global business and investing practices. It basically started off as an investor-led phenomenon, but now it has taken shape as mandatory and voluntary regulations across the globe. And as if we read the term ESG, it stands for environmental, social, and governance. And it encompasses various metrics on which companies are sort of evaluated on the basis of how they're doing as far as environmental considerations are concerned, as far as societal development is concerned, as well as corporate governance. The concept of ESG intertwines seamlessly with business ethics. At its heart, ethics is the study of what is moral, focusing on duties, rights, justice, fairness, and community benefit. This moral imperative applies equally to individuals, groups, and organizations. When businesses follow ESG principles, they show that they are aware of how their actions affect the environment, society, and other stakeholders. They also express a dedicated commitment to being a positive force within their communities. Now, if we look at ESG regulations, I'll just spend a minute talking about this. There are a few themes that we sort of encounter across the globe. The first one is transparency and disclosure. Most countries and regions have laid great emphasis on transparency and disclosures while legislating ESG laws. While some have made these disclosures mandatory, some jurisdictions allow corporations to follow the frameworks established by international associations. Worldwide, ESG laws include provisions pertaining to climate change, environmental stewardship, social responsibility, and human rights. It also encompasses board structures, executive compensation, anti-corruption measures, and overall ethical business conduct. They also encourage companies to engage with the broader set of stakeholders beyond the traditional shareholders, including employees, customers, communities, and other parties. Now, while these are the broad themes of ESG regulations, there are many challenges that still exist. The first is definitely greenwashing. Many corporations manipulate disclosures to artificially enhance their perceived environmental performance. They usually exaggerate positive outcomes or hide negative impacts, often misleading stakeholders about their true environmental efforts. There is an absence of universal ESG reporting standard, which further complicates transparency. With numerous frameworks and metrics available, companies often struggle to consistently convey their sustainability efforts, and this lack of standardization makes it difficult for investors as well as consumers to compare and evaluate the true corporate performance effectively. Further, there is data fragmentation where ESG related data is sort of scattered across corporation. So various divisions are involved and half of them don't even know what they're working towards. There's also varying levels of knowledge. Effectively communicating complex ESG data in a manner that is accessible and meaningful to all stakeholders is not only challenging, but it's also something that even the top management struggles with. And finally, there are issues with transparency, which are perhaps the most pressing. Stakeholders demand clarity and certainty in ESG evaluation, but inconsistency in data quality, verification processes, and communication can lead to skepticism and doubts. First, now another aspect I want to focus on is how the top management, the middle management, even the lower management is not very comfortable with what ESG stands for. They're not very adept at soft skills. So if we talk about corporate lawyers, they're not very good with what works for the society in general, and there is a general lack of soft skills. The companies comply for the sake of compliance, but the executives are not really trained to ensure that their actions lead to proper impact. And that is where natural law theories can be of help. Now, at the core of the ESG issues that I just spoke about is the responsibility of corporations to respect the natural rights of all individuals they interact with, be it individuals like employees, consumers, shareholders, or the broader community. Natural law theory, therefore, provides a foundation for evaluating whether the corporations are doing the right thing and whether their practices align with the ethical norms of justice, especially when these practices impact the environment or involve deceptive behaviors. As decision makers and stakeholders in the corporate world, it is imperative to balance profitability and ethical obligations. By incorporating natural law concepts into the ESG decision making and disclosure procedures, professionals may gain insights that allow them to focus on the broad goals of social welfare and environmental stewardship. Now, there are three theories that I would be focusing on, and why I've chosen them is because they have a lot to sort of provide to business ethics, and there's a lot of literature on how these natural law theorists sort of contribute to business ethics. The first one is Immanuel Kant. Scholars in the field of business ethics have demonstrated how Kantian ethics can direct companies towards practices that prioritize stakeholders' interests over profit maximization. Kant argued that the highest good was goodwill, and to act from goodwill is to act from duty, and action may be considered moral if it is morally motivated. Now, the first formulation of Kant's imperative commands us to act only on that maxim which you can use at the same time if it were to become a universal law. This principle compels us to consider the universality of our actions. For instance, if a corporation decides to engage in greenwashing, misleading consumers about its environmental practices, we must ask ourselves, what if every company did the same? Such a world would lead to misinformation and breakdown of trust, clearly illustrating the unsustainable nature of such practices. Moving on, the second formulation tells us to always treat the humanity in a person as an end and never as a means merely. This emphasizes the intrinsic value of every individual, urging businesses to respect their stakeholders and not to exploit them. And finally, you should behave as if you were a part of a perfect kingdom of ends, where you are simultaneously sovereign and subject. This vision is particularly relevant to the ESG framework, encouraging companies to foster a culture where decisions are made considering the well-being of the stakeholders involving, also including future generations. The next theory that I talk about is that of Thomas Aquinas. Aquinas argues that our actions must always aim to preserve good, even if that means making difficult choices. For example, in defending oneself, it is morally licit to harm another if it preserves a greater good and the action is proportionate. In the realm of business, Aquinas' thoughts on commutative justice are particularly telling. He warns against the pursuit of profit as an endless goal. Instead, he advises that profit should be a means to support oneself, one family, and society. This again echoes the principle of ESG, which emphasizes sustainable and ethical business practices that benefits all stakeholders and not just shareholders. Aquinas' ethics suggests that ESG regulations should not only mandate transparency, but also ensure that information is not only complete, but also genuinely reflective of the company's purpose. Aquinas also finally demonstrates that disclosing information is an essential act for maintaining human health and salvation, and it focuses on virtue-based framework rather than a consequentialist lens. And finally, I talk about John Finnis. John Finnis again builds on the foundational ideas of Aquinas and has significantly enhanced our approach to ethical decision making within the framework of analytical jurisprudence and social theories. Finnis bases his natural law theory on the principles of Aristotle, that good is the ultimate goal of all human endeavors. This concept transcends mere compliance with rules, emphasizing that our actions should inherently promote basic human goods, which he identifies as life, knowledge, sociability, and other factors. Finnis argues that there is no hierarchy among the fundamental goods, necessitating a moral framework to guide our choices. Expanding upon Finnis's framework, we can see its applications on ESG. His emphasis on promoting basic goods like friendship and sociability aligns with the social aspects of ESG, where corporate success is measured not only on the basis of financial outcomes, but also on the basis of the well-being of employees and the community. His call for integrated management systems aligns with ESG goals that challenges businesses to think beyond traditional metrics and embrace comprehensive sustainability practices. Finally, Finnis also underscores the importance of not showing arbitrary preferences among values, which is critical for ESG assessment. It also means focusing on the long-term commitment to ESG principles rather than just the tick box approach that most of the corporations follow and just following like a short-term approach. That's not what Finnis stands for. Finally, to conclude, in implementing ESG standards, let us carry forward the message that our actions must align with these timeless ethical principles. By doing so, we can ensure that our corporate practices not only drive profitability, but also contribute positively to the world around us. Thank you.
Thank you, Kirthana. Next, we have Stéphanie Panneton from Université de Montréal at Quebec, who will tell us about sustainable clothing. You have 10 minutes. Go ahead.
Can I put it? C'est parfait. Okay. So good afternoon, everyone. I'm very happy to be here among you today to talk about what's been keeping me busy as a PhD student. I often read and hear how clothes are superficial, and it has always bothered me. I wonder how an object so ubiquitous and intimate could be considered superficial. Every one of us has a wardrobe, no matter its size and the type of clothes in it. Every day, and sometimes more than once, we dive into it to pick up the garments that will not only get us through our day, but that will express the way we feel, either consciously or not, on that specific day. Clothes reveal parts of our identity, and clothes have deep cultural, social, and environmental meaning. Did you know that this ordinary daily practice has a major negative impact both environmentally and socially? My presentation today will contribute to the understanding on how the topics and industries we have discussed over the past 2 days significantly affect the environment. So I will start by giving you an overview of fast fashion, which is the main segment of the fashion industry that produces most of the clothes found in our wardrobe, but also literally in the environment. I will then talk about the concept of circular fashion and how it is considered as an alternative to fast fashion. I will present the notion of effective economies, which is one of the theoretical approaches I will mobilize to look at the emergence and state of circular fashion and explore how clothing behaviors could shift towards more sustainable practices. Finally, I will briefly present how I intend to do so concretely. So fast fashion emerged in the 1970s. It is characterized by a low-cost production and sourcing of materials from overseas markets, generating new styles of clothing available to the average consumer every week. Fast fashion has anchored a culture of impulse buying where consumers show an insatiable demand for newness, which with major chain stores such as Zara or H&M offering garments at very affordable prices designed to be worn fewer than 10 times, either because they become out of style or because they've lost their shape or been damaged given their low quality. Gratification is at the heart of fast fashion marketing strategies, where consumers fulfill their desires that are instigated by brands by acquiring what is presented as must-have garments. Such strategies have anchored a form of detachment, disconnect from our clothes. That is the process behind the making of a garment, the people who put them together, and the environmental impact, as their disposal is a socially accepted practice. Finally, fast fashion is based on a linear economic model that is also referred as take, make, waste, or a cradle-to-grave design. The fast fashion industry has 4 key sectors, which are the raw material extraction and textile production, so how to turn a raw material into a fiber, a textile, the design and the garment manufacturing, transportation, which is here shown as an isolated link, but is actually present throughout the entire chain and is one of the main issues given the considerate pollution it has. And finally, the 4th sector is the consumer use and disposal of our garments. So the main issue with this model is that currently these sectors work in silos, and this linear model does not limit the number of countries that contribute to the production of a single garment. In reality, so many countries contribute that one pair of jeans might travel over 65,000 kilometers. So I wanted to briefly give you some numbers that represent what the fast fashion industry is. So it's among one of the most polluting industries with 10% of global carbon emissions. That's more than global carbon emissions, and that's more than flights and maritime shipping combined. It is also responsible for 20% of global wastewater, which are contaminated with harmful chemicals used during dyeing processes, and plastic microfibers emissions through laundry machines. And it is estimated that 100 billion garments are produced each year, and out of that number, 92 million tons end up in landfills, like we can see on this first picture, which represents a coastal landfill in Ghana. On the social aspect, I will briefly go over this section given the time, but fast fashion is The social impact of fast fashion has to do with modern slavery, paired with inhuman working conditions, like we can see on this second picture, which is a room where people from Bangladesh are making clothes that we will eventually buy. And there are also important public health issues related with this industry. In terms of fashion consumption, the number of clothes the average consumer purchases has increased 60% between 2000 and 2014. It has been increasing over the last decade and is likely to continue increasing in the future. We wear on average 20% of the clothes we own in our wardrobe, and about 1% of clothing that is produced, whether it's worn or unsold, is recycled into new clothes. Hence, the industry must change. So, circular economy has been gaining greater attention over the past years as a more sustainable model, especially for the fashion industry. So, in such a model, a garment is designed in such a way to integrate the ecological principles of zero waste and 100% reuse at every stage of the product's life cycle. 4 strategies are proposed by authors that have investigating how to implement circular economy principles into the fashion industries. And these strategies are the following. So the first one is regarding resource efficiency. So that's the use of renewable, regenerative, and non-toxic raw materials. The second is a circular design. So that's designing a garment for its longevity, customization, disassembly, and decomposing. The third one is the product life extension, which falls under the consumer phase. So that's repairing our garments when they need to, swap or rent clothes if we wish to have new clothes instead of buying actual new clothes. And the fourth strategy has to do with the end-of-life circularity. So that's the potential of a garment to be reused, resold, recycled, and remanufactured. So the shift to a circular economy entails changes throughout all stages of the process of production and consumption of materials and energy. And to that, my research adds the importance of changing values and consumption behaviors, as the two are intimately linked. So this is why my research focuses on effective economies. Researchers have largely focused on production and consumption aspects of the chain, but very few focus on the emotions and effect, which to me is the missing link to sticking every link of the production to consumption sides of the chain in circular fashion. I came across a very interesting article where the authors investigated a theory of interpersonal love relationships to explore what makes people keep and wear their clothes for longer, following the notion that waste is symptomatic of failed relationship. So it's the idea of, just like we care for a significant other, a family member, a friend, how can we develop a relationship with our clothes to make them last longer? And the study highlights the emotional aspect that to me is the missing link in how to really encourage ecological transition regarding our clothing attitudes. So we know we must change our structures of production and consumption to really encourage such a transition. Affect here is seen as a lever to change the consumption side of the equation because these behaviors are so linked to values and identities. So I attend to the ways in which clothing circulating in the economy, in the fashion industry, are like signs. My research treats clothing as circulating signs, full of meaning and values, in which consumers invest their senses of selves, collectively and individually. In other words, narratives attach certain feelings and cultural significance to certain styles and encourage individuals to invest emotionally in these values, or to build their identities with these signs and the narratives that put them into motion. I will work at how figures related to circular fashion are aligned to create a narrative of environmental defense towards more sustainable clothing practices. And concretely, I tend to do so by analyzing media articles that cover circular fashion, as well as verbatim from interviews I will conduct with circular fashion retailers, fashion journalists, and circular fashion consumers. I will analyze how these texts contribute to an effective economy and pay attention to what emerges to understand how current clothing practices can shift towards sustainable clothing practices. So I hope with this holistic approach to see how these connections are set into motion in between narratives and practices, and how people insert themselves into the circular effective economy. Thank you very much.
Thank you all for your very interesting presentations. So we move on to the Q&A session. If you have any questions, please go ahead.
Thank you. My question is for Kirthana. I was wondering what your perspective is, because of the nature of business broadly and the drive for profit. I wonder your perspective to the question of, is there any just or ethical profit in business, like broadly? Can a business be ethical? Yeah, what's your perspective?
Is it on? Okay. All right. Thank you for the question. To answer that, I do agree that whenever we think about corporations, we always think that they are running behind profits and they don't really care about the social aspects of the business. But there have been studies where it's shown that companies that are focus on ESG, they focus on their social responsibility, tend to also do better profit-wise. So nowadays, what we see is that the people who invest in corporations, talking about banks, talking about institutional investors, even retail investors like you and me, would consider investing in companies which we feel are doing well for the society, for the environment, right? And we want to associate ourselves with businesses who care about their stakeholders and are not just running behind numbers. So while I do agree that earlier, yes, there was an emphasis on how corporations work only for the benefit of the shareholders, maximizing their wealth. But now there is definitely a shift towards stakeholder side, where investors are now asking corporations how they do on all these sustainability measures that we talk about. So while I do understand that we are not there exactly, and there is a lot to sort of catch up on, but definitely there's a movement towards social good, and hoping that in the coming years we see more companies shift towards stakeholderism and ensuring that they do well for the society.
Yeah, thank you. Can I ask a follow-up question? Is that okay?
Sure.
Thank you. So I guess, hypothetically then, if a company was to follow ESG principles perfectly, would you consider that company to be moral?
I mean, that's one way to look at it. But again, like I said, when we talk about ESG, one, it is about disclosure. So usually corporations in their annual reports will disclose how they meet the E, S, and the G criterion. ESG criteria is also sort of important when we rate companies. So we have ESG rating companies, which the primary focus of there is to say that, okay, this company is doing well as regards environment, maybe not so good as far as social and governance. I mean, that's a hypothetical. But there's definitely greenwashing, which is a problem, where companies sort of portray that they care about the society, they are becoming more green. But if we look at their basics, if we look at how they're sort of undertaking their decisions, they're not really bothered. So that's what I wanted to focus through my paper as well, that we see a lot of corporations, yes, maybe doing good on ESG ratings, maybe doing their bit as far as disclosure is concerned, but they don't really, it's not there within the executives. It's not something that's a part of the corporate purpose. And that's why it's important for us to go back to natural law theories, maybe focus on where it's coming from. Why is it that we are focusing on ESG? It's not something that came up recently, but it's something that we can look back upon natural law, and that's something that is deep rooted within our society and the moral imperatives that we grow up with. So that's the main objective of my paper, and yeah, that's
Thank
what
you.
I focus on.
Yeah, great.
I'm so sorry, I forgot the name of the last person who presented. Stefani. I was just wondering, I really like the presentation, just wondering though, regarding circular consumption, is there any evidence in literature, especially for textile, regarding rebound effects? As we mentioned, there might be, previously, there might be some like gold that goes away if it's circular. So far, is there any like evidence of rebound effect?
So it's one of, so circular fashion is very recent. Researchers have been, done in the past years, 5 to 10 years max. And the rebound effect is one of the critics. So it's one of the red flag, because a circular economy into the fashion industry is certainly a more sustainable model, but one of the things to be careful is the rebound effect. Thinking that because it comes from a circular model, it's better for the environment. I think that the main factor is over-consuming and overproduction. And so we cannot think about circular fashion without thinking about this in front of production and consumption, in order not to fall into le piège du rebound effect.
Thanks.
And thanks for your question.
Thank you so much for all of your great presentation. I wanted to maybe a more general question to all three of you. I think in the background of all of your presentation, I see a topic that hasn't been mentioned, and that is the ideological aspect of capitalism as well, and the fact that you all point in different ways to a quest for accumulation and having more. And I think the previous question to Kirthana regarding profit, I think it's also a question of what do we consider as an outcome that we want to measure, and is profit the right outcome to look at? So I think my question to all three of you is, how do you maybe incorporate this aspect in your research? And how, maybe Stephanie, like when you look at discourse, do you also question maybe the cultural and ideological factors that all of us, we have been socialized to look for accumulation, to look for more clothes, to think that more profit is good?
Well, definitely thinking about circular economy is a change of paradigm when you take it like in practice, and this comes like this idea of thinking about a circular economy has to do with the capitalistic, the capitalism, and as I've mentioned, the main issues here are the production and overconsumption that is encouraged in such a system. And a circular economy will there's all of the links have very legitimate and valuable ideas to put into practice, but it's certainly, I haven't thought of it right now, but for sure I will have to, it's going to be part of the problematic, that I will have, because it's one of the criticism, one of the main criticism of the fashion industry right now is how it operates in such a capitalistic mindset. I'm sorry for my English, but I hope you get the sense of what I'm trying to say.
So, yeah, I mean, I totally agree that when we talk about ESG and we talk about corporations, a lot will depend on the cultural, the political ideologies of the jurisdictions they, are operating in. So, for example, if I talk about the United States, there have been a lot of talk that ESG and all this focus on corporate sustainability is nothing but woke capitalism, and it's nothing but you're trying to portray something which you're not. And I mean, that's the culture there. And I mean, of course, that comes from the capitalist side of how United States is. Whereas I can talk about India because I do a lot of research on Indian corporate laws. India is a socialist country. We talk about how governments sort of focus on upliftment of the society in general, and it's a mix between capitalism and socialism. But what I've seen is that in India, it was perhaps one of the first countries to come up with a mandatory disclosure of the ESG disclosures that I talked about. So this of course this will have an impact on how corporations see ESG and corporate sustainability and things to do with that. But this is one aspect of it, but we also have the market-led side where we see more global investors talking about ESG, talking about corporate social responsibility now. So unless you comply with their requirements, you will not do good profit-wise as well. So if the compulsion doesn't come from the legal side, it comes from the market side, where investors are actually compelling you to change the way you look at business and your actions. So while I do agree that there will be cultural and political sort of like roadblocks on the way, but if there are other market forces which are as powerful, maybe there will be some shift in the ideologies of corporations. Yeah.
So for me, I'm working in a financial market. So capitalism is, so it will be difficult to, but something is sure. We have many papers, and one of them is, a well-known paper by Pastor. He's showing that when climate change concern is increasing, green firms are outperforming brown firms. So now companies are aware of this climate change concern. So they know that, when we invest and when we do our activities and when we do everything in respecting environment, people are more and more willing to invest in those companies. So if everyone is investing in a company like in Tesla, like Nvidia, for sure they will outperform the market. So this is the only way that I can think about environmental practices. But in financial markets, people don't think about everything else than capitalism and making money.
Perfect. I just wanted to say thank you for all of your presentations. They were very insightful, and they're all very different in their own ways. So it really was able, for me at least, to see a very different perspective and kind of change perspectives throughout the course of this session. And I actually have a question for all three of you. I'm sorry I forgot all of your names, but I'll just go from left to right with regards to my question. So for instance, this might just be for me, but as a novice investor, what would be considered a brown stock versus a green stock? And then also, was it specifically related to one sector? Was it related to the technology sector? Was it related to a growth stock or ETFs? Or was it like looking at just individual companies when kind of compiling those cool charts that you're showing us with the decrease of brown stocks and increase of green stocks?
This is a very good question. But you have many ways of differentiating green and brown stocks. In my work, I decided to use the ESG ratings. So this is very objective rating. And we can also use the greenhouse gas emission volumes. So it's a comparison between one stock and the remaining stock. So there is no way of saying this firm is green without paying attention to all the remaining stocks. So when you have your portfolio, when you decide that you want to invest in 10 stocks, this is the moment where you can differentiate and say this is green and this one is brown. And you will find in the S&P sectors, in technology, in health, and all the sectors, there are green and brown stocks. So there is no one sector or one activity that is green compared, just like that. It's always a comparison between many sectors.
Perfect, sounds good. I'll be a millionaire by 30. And then for you, so I've heard a couple of talks relating to ESG, and one thing that I kind of had an overlying question regarding how the natural law implicates, I find in my background, specifically when attending these talks about ESG, was really specific to oil and gas. Is your research on a specific sector? Because as you probably have researched and saw through your research, it definitely changes through the different sectors. And also I'd like to see, has there been changes since you've researched in India versus Canada? Have you seen any major shifts nationally as well?
So I don't really focus on a particular sector. It's from my conversations with ESG professionals and lawyers that deal with CSR and ESG related issues, and the common thread that I found when I had that conversation and I read about their experiences is that there is definitely a lack there, because while they know how to make numbers, work, they know how to make profits, they know, if we talk about a general MBA class, they're taught everything to make a business work. What they lack is, of course, how to make these social actions and, all the relevant issues that I just spoke about in my presentation work. So another paper that I wrote previously was how, when we talk about corporate social responsibility, we have excellent laws across the globe. It's not a new phenomenon, but what we see is that the impact that was desired when these laws were promulgated is nowhere to be found. Of course, companies, they do their best, they comply with the laws, but the results that we expect from them, of course, there's definitely some gap there. And one of the reasons is that the people who are taking the calls, the people who decide what, actions to be taken, they are not really conversant with how things work, and they're good, again, like I said, as lawyers, we are taught how laws work, how to comply with, company laws, securities laws, but we are again not taught about how policies are evaluated, what is the impact of the policies that are put in force by the lawmakers. So what I'm trying to focus on through my research is that we need to again train our ESG professionals and lawyers about these aspects of ESG, about the ethical frameworks and considerations, which somewhere it's not prevalent so far. So when I talk about my studies, I was never taught about impact evaluation. I was not taught about assessment, about what works, what doesn't work, how to ensure that corporations actually work on making a positive impact as far as environment, social actions as far and governance is concerned. So while I don't focus on sectors as much, I'm focusing on how it should become a part of business ethics, and it should be taught to professionals who deal with these decisions on a daily basis. So yeah.
Perfect. Yeah, looking at it more from a bottom up than a top down approach to really bridge that gap and hopefully in a way
but that's a good
aid the data collection process, because once everybody understands from the lowest level worker to the highest upper management, then it's really easy to
but that's a good suggestion. Maybe I'll read more about how it varies from sector to sector, and maybe there are a few sectors where we have more experts in place, whereas other maybe oil and gas, yes, is a good sector where we may have some experts on environment and CSR being a part of their main team. Maybe not so much in core financial institutions. So that's a good feedback, and I will definitely read more about it. Yeah, that's a good idea.
Yeah. Thank you. Yeah, and then my final question, sorry for taking up the mic, guys, relates to the discourse analysis that you're initially proposing. And I found it quite interesting how you are planning to interview all like subject matter experts in the field, but then the decisions technically are made by the consumer. So have you considered looking at potentially using social media data or looking at potentially doing surveys post-purchase to see the consumer side of things, to really grasp that holistic conversation, really kind of get the contrasting views of the fashion industry?
Well, I will definitely interview consumers who either their wardrobe is partially or fully circular. Yes, right now I've identified, I'm gonna have to make choices. So I've considered analyzing, social media, but at the same time, there are lots of articles. I'm thinking about, I'm reading a lot about Vogue Business and Business of Fashion, which are two fashion media who write extensively on circular fashion. So I will, at this point, I would say that I do not intend to look at social media, but maybe eventually the need will come up, and then, my method will be flexible and I could consider it. But it's just a matter of managing, the flow of text, of articles, and focusing onto one just to be coherent in the methodology.
That makes sense. Yeah, I was just about to say, once you add social media, and it's a whole new realm,
Definitely.
to say the least.
Yeah.
Perfect. Thanks, guys.
Thank you.
Thank you. Stephanie, question, and also Abdoul Aziz. Stephanie, question for you in the circular fashion. The one thing that you didn't mention, and I'm just wondering if there exists, is any look at transportation and whether there's a counterpart in fashion to what we've seen in food, where there's the local food movement, whether we have a local fashion movement, without getting into hand-woven earthy textiles and felting and stuff like that.
Yeah, the idea in circular fashion is to certainly, and it's true that I did not mention it, but it's to bring back the production and consumption at a closer, more local level. And I know there's an initiative, I don't know if you've heard of it, Fibershed. So Fibershed is a model which started in California, and right now you have several fiber sheds all around the world. And the idea here is to produce and consume, so do the entire loop within, I don't remember the number of kilometers, but within a certain
radius.
Yeah, correct.
Okay.
And so circular, and so this what does is that obviously transportation, which is one of the most polluting aspect of the industry, is largely reduced, and that's the aim, the goal of it. So I know you've mentioned the woven knitted, but there's also.
I know, I don't mean to be sneery, but I was just thinking of distinguishing industry from craft.
Yeah, correct. But the craft is definitely coming back into that idea of circularity, and it's also we're also working at UQAM. So there's a Fibershed Quebec that was launched, I believe, a year ago, where we would like to see how we can restart, because all of this is not new, correct? It's just a matter of going back to the way it was done before, and so how we can revaloriser, but wool, hemp, and so these local fibers that we can grow here in Quebec, Canada. So it definitely takes into consideration the local aspect of producing fashion as well as consuming it.
Thank you. Thank you. Very interesting. Actually, all three of you, very interesting presentations. I really appreciate it. But Abdoul, Aziz, I have a question about one aspect of your presentation where you talk about investor preference. And you gave the impression in your talk and also in the question you answered earlier is that this is somehow like a monolithic thing, investor preference. And I'm sure my amateur sense is that it's not the case. There are different kinds of investors. And I'm just wondering to what extent this issue of both volatility and profit appeals only to very specific kind of investor. And if it is a specific kind, how big a proportion of the investor sector does that represent?
I don't know, because this is very complicated to.
So, sorry, let me sort of, when I was thinking about investor preference, what you had in your presentation was that investors prefer long-term stability, and yet, I'm sure we all know of, and we've certainly read of investors who prefer quicker returns. So, can you deal with investor preference in a sort of a uniform way like that?
Not directly, but when you decide to invest in a stock, you choose some parameters, you have some preferences. You can say, okay, I'm gonna invest this amount. I want this level of risk. I want ideally this level of return. I don't want to lose this amount, and I want a stock that is 20% green. So this is parameters. So each investor has its own parameters and sensibility. We call that utility function in econometry. So it's very, let's say, different from each investor. So they have many algorithms. That's why in financial market, it's not, I don't know how to tell in English, it's pas un jeu à somme nulle. We can all win, we can all lose, so there is no way of finding one good solution. And if we have one good solution, one good algorithm, all the strategies will have zero return because everyone will do the same thing. And if we all do the same thing, we won't find new returns. I don't know how to rephrase that in.
I think I understand what you're saying. That if it were totally uniform, it would be like a zero sum kind of.
If you're all doing the same thing, there is no way of finding arbitrage. Let's say that again. Because in financial markets, what we want is when we find that there is a way of investing in something, it's because we have one information that other people don't have.
Leverage, then.
Yes.
You're looking for leverage.
So if we have all the same information, we're all going to invest. And if we all invest, there is no way of selling the stock to someone that hasn't invested yet.
Okay, thank you.
Unfortunately, that's all the time we have for questions today, so I'll hand it on over to Alexandre.
Okay, so this is it. Thank you all for joining us today. This ends the conference. We're done with the presentation, but the day is not over yet. Those of you who signed up for the cocktails, please join us in about 10 minutes at McKibbin's right there. Good evening, everyone, and don't forget to give us back your badges because we're going to reuse them.
Thank you, everyone. Thank you to all of those in the space and online who have contributed today to CIREQ's Interdisciplinary PhD Student Symposium on Climate Change. Congratulations, everyone, on the 4th year in a row. As Alexandre mentioned, you're all moving over to McKibbin's for an after celebration. Congratulations and have a great evening. For those of you online, we're going to be closing up the Zoom and the live stream. But just a reminder that you can already find this available on our YouTube if you'd like to share. Thanks, everyone.